Okay, folks, in our last video, we were talking about nomenclature of aldehydes, and I know that you were having so much fun learning everything about naming an aldehyde group, right? I mean, yeah, where else can you get this kind of information and this kind of fun for free? Well, it's not really free. You pay tuition dollars for it, so you might as well get the most of it. So we were talking about the nomenclature of aldehydes. And if you go and take a look at the lineup here, I've got number 1, number 2, number 3. Well, I'm going to skip number 2 for just a second. And the reason is because I want to go ahead and go to number 3, where we are looking at a molecule with multiple functional groups and how to name them. So we've talked about a type 2 functional group at this point, and that was an aldehyde. So what if we had a group that was an aldehyde group? So, in other words, a C double bond OH, and then let's say off of this aldehyde, we have a CH2 and a CH and an OH and a CH3. Well, how do we name something like this, right? And if you look at what I've done here, I've taken an OH group that we learned at the beginning of the semester, which is an alcohol, and we talked about how to name alcohols during that time. And now I've mixed that in with the aldehyde group that we have just learned about. So how do we name these types of functional groups or compounds that have multiple functional groups? Well, we need a chart. I know. It seems like everything we do needs a chart. Well, good news is that I don't require you to memorize this chart. This chart will be provided to you at all times, and this is what the chart looks like. So if you do have the textbook, and you've at least cracked it open, you're going to find this chart in the chapter. Well, what this does is that it sums up pretty much every functional group that we have discussed at this point, except for a ketone. We've not talked about that, but it's on the chart. And it gives them a ranking. It gives them a priority. So if you look at the chart up here at the very top, it says carboxylic acid. And this arrow points up, and that says increasing priority, which means that the carboxylic acid, folks, when it comes to nomenclature, that's the key word, nomenclature, right there, is going to get priority over everything else. That means if there is a C double bond OOH group on a molecule, you go there. You're going to name it as a C double bond OOH, which is a carboxylic acid. And you use the rules for carboxylic acid in order to name that compound. It beats out everything else that's on this chart. Well, what else is on the chart? Esters, which is type 1. Amides, which is type 1. Nitriles, which we regarded as type 1. Aldehydes, which are type 2. Ketones, which are type 2. And then everything else that we've discussed up to this point. Alcohol groups at the beginning of the semester. The amine group in Chemistry 251, the alkene group in Chemistry 251, the alkyne group at Chemistry 251, the alkane group in Chem 251, the ether and the alkyl halide, all from Chem 251. Folks, there you go. That's the order of the chart. Every functional group that we have talked about in Chem 251 has a lower priority than every group that we've talked about in Chemistry 252. Who would have ever thought it? Who would have known that we would structure it this way? But that's the way that it kind of fell in place. And then in addition to that, type 1 gives the priority over type 2. So type 1 carbonyl, type 1 carbonyl, type 1 carbonyl, type 1 carbonyl, and then these aldehydes and ketones are type 2 carbonyls. Type 1 carbonyl gets priority over type 2 carbonyls when it concerns nomenclature with multiple functional groups. All right, so that's the order of the column over on the left-hand side. Now let's talk about the other two columns, because they're important too. And in the second column, this is called the suffix, and this is called the prefix. Why two columns? There's got to be a reason, right? There's got to be a reason for this, a suffix and a prefix. What on earth does that mean? Well, prefix means come before. So if something comes before, we typically put it in front of the name. All right, so if I'm doing a name of a molecule, whatever goes in front is typically the prefix of that name. So for instance, 2-chloro-4-methyl, that is the prefix. So what this means is that if you have two competing groups, and let's say there's an alcohol group like we have on this example that we've just drawn, and we also have an aldehyde group. There's two of these. I'll explain those in just a minute. The aldehyde beats the alcohol. Both of them are still there, folks. We still have an OH there. We still have an aldehyde there. They're both present. How are we going to name them? So the aldehyde comes first, which means that this particular carbon, this right there, that's the priority carbon. All right, so if that is the priority carbon, then the alcohol group we have to name. And if the alcohol group is not the priority, this is what we name that alcohol group as. Meaning that wherever the OH is located in the molecule, we're going to name that OH group as a hydroxy group. And we name it at the beginning of the name as a prefix name. The suffix name, this is the parent chain. It's telling you how to name the parent chain. So if this aldehyde is present, and we do have one, then we're going to name this molecule as an aldehyde over the alcohol because the priority is higher. Well, in the name, we're going to end up with an AL ending. So that suffix name, which is the parent name, will end in AL. That is what that is trying to tell you. It's giving an order to the madness. And then we name the alcohol group. Well, we don't name it OL because that's if it was the main chain. And it's not. The aldehyde's the main chain. The alcohol group needs to be named, though, and it needs to go in front of the AL, the aldehyde name. And that is going to be a hydroxy. In other words, what this means. IUPAC. How many longest carbon chains? 1, 2, 3, 4. There's 4 of them. Okay, so butane. There you go. Well, I have an aldehyde and I have an alcohol. Aldehyde takes priority, so whoop, get rid of the E and add AL, butanol. Okay, well, on butanol, on carbon number 1, because I just named it as an aldehyde, that means that's the first carbon, carbon 2 and carbon 3 and carbon 4. On carbon number 3, I have an OH group. Well, how do I name this? I'm not naming it as an alcohol, I'm naming it as an aldehyde. What name do I give the OH? That's the chart. That OH is going to be called hydroxy. So, in the IUPAC nomenclature, this is a 3-hydroxy butanol. Folks, there you go. There's the magic of the chart. It tells you everything you ever need to know about any functional group that we've talked about up through this part of the semester, and including last semester. So the name of this compound is 3-hydroxybutanol. I can also common name this, right? The common name for a 4-carbon chain is butyr. So there's the butyr part. I add the entire word aldehyde because I'm naming it as an aldehyde. So butyraldehyde. And this is the alpha carbon, and that's the beta carbon, and that's the gamma carbon. So beta hydroxy butyraldehyde. That's how we can common name that particular type of structure. All right. Okay, so there's one example down. So now that we know how to read the chart and what it's trying to tell us, let's do another example to feel maybe a little bit more comfortable with this. All right, so here's a C double bond OH, and this time I'm just going to do a skeletal structure off of this. All right, so I'm going to write that carbon just so that you understand that it is a carbon, of course, right? So here is a zigzag, zigzag, zigzag down, and here is a double bond O with an O that's there. And then this will end up with a CH3. Name it. Oh, goodness gracious. It's not hard. Let's just kind of put a procedure to the madness. Let's use our chart, and everything will be okay. C double bond OH. Hopefully you will recognize this as an aldehyde. C double bond OO. Oh, look at there. C double bond OO. Do you remember what that was called? I hope so. That was the last module. That's an ester group. Smelly, wonderful, good things. Esters. So I've got to figure out, which one is going to come first, ester or the aldehyde? Well, let's kind of think about the way that we presented this. That chart, we typically said type 1 carbonyls are on top. They get priority. Well, let's see if that's true. So here's the chart. And let me erase all of this garbage that's here. And we have two functional groups. And those two functional groups are the aldehyde and the ester part. So let's circle those just so we know where we are. So the ester, look, right up here at the very top. And then the aldehyde. Oh, so they're right here. Y2, again, I'll mention that in just a minute. Just give me some time. Bear with me. So just like we predicted, an ester is a type 1 carbonyl that's typically up to the top of the chart. The aldehyde's a type 2 carbonyl that's typically lower. So esters get priority over aldehydes. So what that means in this structure is that I'm going to have to name it as an ester first. That's how I'm going to have to name this thing. As an ester. I use ester nomenclature rules. Do you remember those? I hope so, because we didn't talk about them very long ago. So the ester rules stated that you name the piece on the O first. Okay, so that is a CH3, which is a methyl. And then the longest carbon chain, 1 and 2 and 3 and 4 and 5. Okay, so 5 carbon name. What is it called? IUPAC. Well, that's a pentane. PENTAN. Don't add the E, because we're going to the E off, and we're going to modify the ending. The esters, do you remember what kind of ending the esters got? I do. Do you? Well, if not, the chart tells you. It tells you the ending should be 08 if you're going to name it as the ester, and that gets priority. You're going to end the name in an 08 ending. Oh, well, look, that's a nice little chart. So, OATE, methylpentanoate. Okay, but that's not the only thing here. And the reason it's not the only thing here, because we're leaving off a piece, and that piece, folks, it's this group here. It's that group. We have to include that group at nowhere in the name at all. Nowhere in the name. Does it give me any idea that a double bond O is present at the very end of this thing? The pentanoate, yeah, we included that in the name. But the other carbonyl, the aldehyde piece, I would have no clue. If you just give me methylpentanoate, I'm leaving off a big part of the molecule. So how do we name it? That's the kicker. How do we name it? Well, if I go back to this chart, I'll see aldehyde listed twice. Well, no matter what, if aldehyde beats out any of these other groups, you're going to end it in AL, because that's how aldehydes end their name, in AL. So that's why both of these are the same. But over here, the prefixes, well, the reason they list them twice is because it really depends on how the aldehyde is part of this. Notice the difference here. The difference is a double bond O and then a CH double bond O. One is called oxo and one is called formal. And this is really the kind of confusing part to most people, because they're going to look at this and you're going to see your structure and you're going to go, oh, C double bond OH. Well, then that means this chart's going to tell me I need formal. That's wrong. That's not correct. We have to use oxo here. So if this is carbon number 1, and this is carbon 2, and this is carbon 3, and this is carbon 4, and this is carbon 5, that carbon is part of the main chain, right? I mean, that literally is part of the longest carbon chain. And if it's part of the main chain, then you're really only naming here the C double bond O group. Look at what I circled. I circled it for a reason that way. You're only naming the double bond O because the pentanoate has already taken care of that 5th carbon right there. So if you go back to this chart and you see the double bond O that's drawn, that is why it's drawn that way. Because the carbon is part of the longest carbon chain, which means that you need to name this as a oxo name, OXO. So on the 5th carbon, we have an OXO ending. Now I'm going to do a little bit of rearrangement, because the rules of the esters basically said, you name the piece on the oxygen first. Okay, so that is methyl, and we've named the piece on the ester part, the oxygen part first. And then the rest of the name comes after that. So this is the longest chain over here, and I'm just going to group that together. So 5-oxo pentanoate is going to be the proper IUPAC name for that structure. So methyl 5-oxo pentanoate. Now, the question is, well, what if I get the methyl and the 5-oxo confused? Are you going to count it wrong? And the answer is no, I'm not going to count it wrong. That's perfectly okay with me. It's not going to be okay with Blackboard. It's not going to be okay with a standardized test, but it is okay with me. I'm perfectly fine with that. So if you do flip the 5-oxo and the methyl around, no sweat. You get credit, folks, because all the pieces are there. They're just not in the right order, and that's okay. All right, so methyl 5-oxo pentanoate. Now, what if we had a common name this? Can we do that? Well, yeah, sure we can. We could common name an ester, can't we? So the CH3 part, it stays the same. That's still methyl, all right? So this is IUPAC up here. Well, if this is carbon 1, okay, so there's 1 carbon and 2 carbons and 3 carbons and 4 carbons and 5 carbons in a row. What's the common name for 5 carbons? Valer, V-A-L-E-R. Good, there's Valer. Well, do you remember what ending an ester gets for a common name? It's kind of like O8 without the O. So valerate is going to be the common ending of that. Methyl valerate. But we still have that oxo unit. I mean, that doesn't go away. It's like a chloro. We would still have to name it. It's like a ethyl group. We would still have to name it if it was there. There's no difference here. And it's still on the same carbon. We just can't use 5 as the number. So this is alpha. And this is beta. This is gamma. And this is delta. So I'm going to rearrange it again because I didn't leave me enough room. Here, let me just erase this. Methyl comes first. That's the order. That's what it tells me to do with an ester. And then it looks like delta oxo instead of 5-oxo. And then valer because of the 5 carbons. And 8 for the ester piece. So methyl delta oxo valerate is the common name for that structure, or methyl 5-oxo pentanoate is the IUPAC name for that structure. All right, let's keep going. Let's do another example. This is probably going to be our last one for the video, but we're going to do another one. So let me just give you a full-blown skeletal structure here. There you go. Name that hieroglyphic. Okay. Show somebody this, you'll impress them. I promise. All right, so we're going to have to come up with a name for this thing. Probably an IUPAC and a common as well. And I've got two competing functional groups here again. Sorry, I left off a piece. So we've got two competing functional groups. Now let's identify those functional groups. What do we have? Well, very similar to what we had in the previous example. That's why I did this one right after that one. So C double bond OO, this is a ester. And then a C double bond OH, well, this is going to be the aldehyde. So just like before, an ester and an aldehyde, the ester trumps out the aldehyde. The ester is a type 1, the aldehyde is a type 2. Esters get named first, so I'm going to name this with an 08 ending. Whew, we learned that in 20 minutes. Can you believe that? All right, so how do I name this? Well, look at this little skeletal structure. There's a cute little carbon here and a cute little carbon there. This 2-carbon piece is called a ethyl. The ethyl goes in front, just like always when we named esters. Okay, so what's next is that I need to find the longest carbon chain. All right, so a 1 and a 2 and a 3 and a 4, and I might want to go down to number 5. But that's not my longest carbon chain, folks. This is carbon 5, and this is carbon 6. There's actually 6 carbons in a row. That's my longest carbon chain. It's okay if the other functional group is not part of this. That is not really the rules of IUPAC. My main functional group is part of the main chain. That's all that matters. All the other ones, we name and modify that a little bit differently later on. So I have a 6-carbon longest chain. That's always been the rule of IUPAC. And a 6-carbon chain is going to be called a hexane. Drop the E. And then add 08 because that is the ending that an ester gets. A hexanoate. So on carbon 1 and in carbon 2 and carbon 3 and carbon 4 and carbon 5 and carbon 6, on carbon 4, look at what I have here. This is a substituent. If that was a Cl, you would call it chloro. If that was a Br, you would call it bromo. If that was an OH, you now know to call that a hydroxy. But instead, it is a carbon double bond OH. Folks, that other part of this chart that we talked about, that is why there's a second one listed. Because if the aldehyde is part of the main chain, we name it oxo. But if the aldehyde is not part of the main chain, we call this formal. Notice this is the name of a CH double bond O, a full-blown aldehyde group, and that's why both of these are listed the way that they are. So they do have different names that they go by. This is the full-blown whole molecule, not part of the main chain, and we call this the formal group. Now, again, I'll come over here to the side. Not part of main chain. There you go. Not part of the main chain. It's a formal. If it is part of the longest carbon chain, we name it something different because we've already taken care of the carbon. We're only naming the oxygen at that part, and that oxygen is going to be called the oxo unit for oxygen. Get it? That's why we have those two names. So if I look at this structure, this is not part of the main chain. I need to name it all, carbon included. Oxo's not going to work. It's only really for the oxygen. This is an oxygen and a carbon. So on carbon number 4, I'm going to have the formal functional group or substituent name. Ethyl 4-formal hexanoate. That is the IUPAC name that this structure goes by. All right, now let's take a look at common name. No big deal. 2 carbons. Huh, still ethyl. What do you know? Well, that carbon is my carbon of the carbonyl. So this is the alpha and that is the beta. And this is alpha, beta, gamma. So, gamma. I still use the word formal. That doesn't change anything. Now, the common name for a 6-carbon chain. That's my longest chain. Hexanoate is IUPAC. What's common? Do you remember? Well, Valera was 5. And K-Pro was 6. And this is a caproate. An ethyl gamma formal caproate. That is the common name for that structure. All right. So that's where this video is going to stop. There's 3 examples with combinations of functional groups. I think that you're feeling more comfortable about how to handle these. So if we've got an ester and an aldehyde, or what we'll see in some of these other examples, some other functional groups that we haven't worked with yet. So we'll get to that point. We'll talk about how to name these. And the more examples we do, the more comfortable we feel with them, and the easier these questions are going to get. So stay tuned. In the next video, we'll continue on with examples, and then we'll work ourselves up to the next functional group, and that's going to be our ketone.